In this video, we are going to talk about hypothesis testing for the difference in two population proportions, P1 and P2. The test statistic for testing two population proportions is P1 hat minus P2 hat, where P1 hat is the sample proportion taken from population 1, P2 hat is the sample proportion from population 2, divided by the square root of p hat 1 minus p hat 1 over n1 plus 1 over n2, where p hat is this expression n1 p1 hat plus n2 p2 hat divided by n1 plus n2. Here are the different alternative hypotheses and the critical regions for which we will accept the alternative hypothesis if the z statistic falls within these critical regions. Let's take an example of how to apply this formula to test the difference in two population proportions. A recent San Diego survey asked the following question. If you had been aware that before Schwarzenegger ran for governor, he had fathered a child outside of his marriage, would you still have voted for him? So Schwarzenegger is the Terminator guy, I'll be back guy. Out of 136 males surveyed who had voted for Schwarzenegger at least once, 78 of them said they would still vote for him, and out of 128 females, 48 said they would still vote for him. At 5% significance level, do these data convince evidence? So, do these data provide evidence that suggests that there is a difference between proportion of male and female San Diego residents who would have voted for Schwarzenegger had they known he had fathered a child outside of his marriage? Okay, so basically, is there a difference in the way males and females perceive? Uh, yeah. Okay, so let us let N1 be the population of male voters. So in this case, it's 136. N2 be the population of female voters. In this case, it's 128. This is the males. I believe males, females, and the population sample proportion of males who would vote for Schwarzenegger again is 78 over 136. And population of females who would vote for Schwarzenegger again is 48 out of 128. So in this case here, the null hypothesis is that both population proportions are the same, and the alternative hypothesis is that they're different. So this is a two-tailed test. Here we have 5% significance level, right? 5%. So in fact, here our z alpha of 2 is z 0.025, which is, we know it's 1.96 from before. And let us calculate our z statistic, our test statistic. So the formula again is P1 hat, which will be provided for you on the final exam. P hat 1 minus P hat times 1 over n1 plus 1 over n2 square rooted. So then this will be 78 over 136 minus 48 over 128 divided by... Okay, so let's figure out what P hat is. P hat is on the side. Here it is. N1 P1 hat plus N2 P2 hat over N1 plus N2, which is 70 136 times 78 over 136 plus 128 times 48 over 128. 136 plus 128, which in fact is 78 plus 48 divided by 136 plus 128, which you can figure out actually would be 21 over 44. So this factor is 21 over 44 times 1 minus 21 over 44 times the square root of 136 plus 1 over 128. In fact, the test statistic will be, in fact, 3.22. So if you look then, this is in fact, you compare, right, compare this and these two numbers. Here's the critical region. Oops. Critical region Z alpha over 2 minus Z alpha over 2. And in fact, this test statistic here falls outside in a critical region. So therefore, the test statistic is greater than Z alpha over 2, which implies that that we accept or reject the null hypothesis or accept the alternative hypothesis. Okay. So in fact, there is sufficient evidence that there's a difference between evidence to support there's a difference between voting patterns between female and male voters. In voting between male and female voters. Okay, let's go to our next example. The USA Today Gallup poll surveyed 1,145 unemployed and 675 underemployed. So underemployed just means that they're part-time or they have a full-time job but they're not given enough work. 27% of the unemployed and 25% of the underemployed said they had major problems in relationships as a result of their employment status. Due to that convincing evidence to suggest a difference between the true population proportions of unemployed and underemployed people who had such problems, use a 5% significance level test to see whether there is a difference. Okay, so in this case, let N1 be the population of unemployed, and let N2 be the population of underemployed. And we know that the sample proportion of unemployed is 27%. Sample proportion of underemployed is 25% who have problems in relationships. Our null hypothesis is that the two population proportions are the same. And of course, our alternative hypothesis is that they are different. And we have a two-tailed test, which means that Z alpha means Z alpha 2. Again, it's 5%, so alpha is 0.05, so Z alpha over 2 is 0.025. We know that's 1.96 again from previous studies and examples. Let's calculate our Z statistic now, or test statistic. I'll just insert the numbers. So it's P1 bar, P1 hat minus P2 hat over. Okay, so we have to figure out this P hat again. P hat is N1 P1 hat plus N2 P2 hat -1%. 2 in this case, it is 145 times 0.27 plus 675 times 0.25 divided by 1.5 675, which is 0.263, I believe. So this will be square root of, remember p hat, right? 0.263 times 1 minus p hat, 0.263 times 1 over n1 is 1 over n2. And the test statistic will be 0.9366. Okay, so let's compare these two values. This is Z alpha, and this is our test statistic. So clearly here, our test statistic falls inside the non-critical region. So this implies that we do not reject the null hypothesis. So we accept the null hypothesis. And so there's not enough evidence to conclude that there's a difference between unemployed and underemployed in the relationships. There's no evidence to conclude there's a difference between unemployed and underemployed people in their effects on their relationship.